Okay, good morning students. Today we are going to discuss about Bohr's model of an atom. So this is a concept that comes under energy levels or orbits. So there are four basic postulates of Bohr's theory. Number one is that of atom consists of heavy positively charged nucleus in the center surrounded by electrons. So if we assume the atom, then we can draw the diagram of an atom in such a way as shown in the figure, where there is a circular center where lies the nucleus, and it is the positively charged nucleus. It is surrounded by atoms, and these are circular orbits. As we know from our previous knowledge, electrons revolve around its particular orbits. So according to Bohr's theory, this center is surrounded by electrons of an atom. So I have not drawn here, but electrons are present in its orbits. So it is said that the electrons in an atom revolve around the nucleus in circular paths which have a fixed value of radius and energy. So as these electrons revolve, it has a fixed radius from the center. If we consider it as a circle and this positively charged nucleus is its center, so if we measure the distance of these particular electrons, we see there are certain radius that it follows. So if we measure, the radiuses are different from each other. They have fixed, this electron has a fixed radius, this electrons has a different fixed radius than this. So, and it also has different energies. So these paths, this path where the electrons are traveling are called orbits, as I have mentioned. And these orbits are associated with definite energies and are called energy cells. So these orbits we can also termed as energy cells or energy levels. And these energy levels are numbered as 1, 2, 3, 4, etc. As you can see in the figure. So I have termed, and this 1, 2, 3, 4, we can also designate them as K. 1 stands for K, then 2 stands for L, 3 stands for M, 4 stands for N, etc. And it will continue. So the next thing we need to remember in Bohr's model, the second postulate says that energy of an electron in the orbit does not change with time. Therefore, orbits are called stationary states or allowed energy states. So what does it mean? It means that energy of these orbits does not change with time. So it remains fixed. And the third postulate also, it says that only those orbits are permitted in which the angular momentum of the electron is a whole number multiple of h by 2 pi, where h is Planck's constant. So what does it mean? It means that an electron, like any other moving body, moving in a circular path, has an angular momentum equal to mvr. That means this is the center, electrons are moving, suppose. So this moving body, this moving electrons has an angular momentum, and the angular momentum we can represent as mvr, where m is the mass of the electron, moving with velocity. It is moving with a circular velocity v, and it also has a certain radius called r of the orbit, this, and it has a this. Suppose we are considering this electron, it is moving with a, it is having a certain mass and it is moving with a certain velocity, and the distance from its center is the radius r. So thus, according to Bohr, the angular momentum is a whole number multiple of h by 2 pi. That means the Planck's constant. So in order to, we can represent it as mvr is equals to nh by, we replace this symbol with a constant that is called n h, where n is equals to 1, 2 and 3, where n is equals to 1, 2 and 3. Is it visible? Okay. So in other words, we can say the electron may be represented by angular momentum of h by 2 pi n equals to 1. When the electron is at, or h by 2 pi n equals to 2 or n equals to 3. That means when the electron is at the first shell, energy cell, n equals to 1, its angular momentum will be, if we replace n with 1, it will be h by 2 pi. Then if the electron is in another energy level, that means here, then the value of mvr will be equals to 2 into h by 2 pi. So this is the second, this is the third postulate, and there is also another fourth postulate which says that energy is absorbed or emitted only when the electrons jump from one energy level to another. So basically this is very easy, as we already understood. When the electrons are in its original energy level, then it will not emit any kind of energy, or it will also not absorb any energy. So once these electrons are excited and it jumps from one orbit to another, then energy is emitted or it is absorbed. So these are the four basic postulates of energy, and this energy absorbed we can represent as E2 minus E1, and energy emitted we can write as E2 minus E1. And that means this amount of energy emitted or absorbed is given by the difference of energies of two energy levels concerned. We can also represent it as delta E, that's equals to E2 minus E1, where E1 and E2 are the energies of two energy levels. That means if we consider, suppose the electron here as number 1 energy level, if it jumps to number 2 energy level, that means 1, and 2. So E2 minus E1. And del E is the difference of two energy levels. This means that emission and absorption of energy occur only in discrete value equal to difference in two energy levels. And in other words, we can also say that electron cannot change gradually continuously but changes abruptly as the electron jumps from one energy level to another and not in any value. This explains the fact that atomic spectra are discontinuous. So this is all about Bohr's atomic theory and its postulates. Thank you, students.